Welcome. In this video, we will learn some basic operations that we can perform on images. For example, grayscaling the image, rotating, cropping, flipping, etc. Here, I have used CV2 library to perform these operations. In addition, as and where possible, we will learn how we can do the same thing by manipulating the array of the image using just NumPy library as well. So we start off by loading necessary libraries. We loaded NumPy library, which is used to manipulate arrays and to perform mathematical operations. We loaded CV2 library, which is the Python interface for OpenCV, and here we have used it for image preprocessing. We have loaded matplotlib library, which is used for visualization purposes. First of all, we start by reading the image. For that, we make use of the imread function. To this function, we pass the path of the image that we want to load. It then loads the image into form of a 3D array. The first term in the shape of the array corresponds to the height, the second term corresponds to the width, and the third term corresponds to the channels. There are 3 channels in a color image, namely blue, green, and red. It should be noted that imread function loads a BGR image, which is displayed here. But the original image is an RGB image, and matplotlib also requires an RGB image. So we need to convert our BGR image to RGB image. This can be done in 2 ways. The first method is by using cvtcolor function offered by CV2 library. To this function, we pass our BGR image and the parameter cv2.color BGR to RGB. As you can see, our BGR image is now converted to RGB image. The same thing can be done by swapping the array of the image. You can see that it requires only one line of code. After swapping the BGR image, we get an RGB image. As you can see, the results in both the ways are similar. Next, we grayscale the image. This can also be done in 2 ways. The first way is obviously by using OpenCV library. What we do here is, while reading the image itself, we pass in the parameter imread grayscale. It specifies to load the image into the grayscale. As you can see, on displaying the image, we get a grayscale image. It should be noted that here the BGR image is converted to the grayscale. The second method to grayscale the image is by using NumPy. What we do is, we are just normalizing only one channel of the image. 0 here represents the first channel, which is the R channel, which is the red channel. We are dividing it by 255 because each pixel in this channel ranges from 0 to 255. So by dividing 255, we are essentially normalizing the image, and all the pixels will range from 0 to 1 only. So on displaying, we get a black and white image. As you can see, we are performing the same function in 2 ways. Next, we resize the image. Resizing the image generally means altering the height and width of the image. For this, we can make use of the resize function offered by the CV2 library. To this function, we are passing the RGB image and the desired height and width. As you can see, the image has been manipulated, that is, it is resized. We can resize it in any way we want. We can also alter the height and width of the image in the form of ratios. For example, let's say if we want to manipulate the width and height of the image to the half its value, that we can perform it this way. Next, we flip the images. To flip the images, we make use of the flip function offered by the CV2 library. To this function, we pass the image that we want to flip along with the flip code. The flip code is basically the name of the axis on which we want to flip the image. 0 represents the x-axis and 1 represents the y-axis. If we are flipping the image along the x-axis, we are basically flipping it vertically, which means upside down. As we can see, the image has now been flipped vertically. If we pass in 1, we are basically flipping the image horizontally. That is, we are flipping the image along the y-axis. If we want to flip the image both vertically and horizontally, we pass in -1 as the flip code. As we can see, this image is both vertically and horizontally flipped. Next, cropping images. Cropping an image means extracting out a particular part of the image from its whole. And it can be achieved without the use of any particular library. We can simply index the array from a specific range along its height and width to get the cropped image, as shown here. Next, rotating the image. For that, we import a library called imutils, which consists of some utility functions to work with the images. So there is this function offered. There is this function offered by this library called rotate, to which we pass the image and the angle by which we want to rotate it. And simply, just like that, we can get the rotated image by 45 degree and here by 90 degree. All these operations that we have just learned can be used to introduce some kind of slight variation in the image in order to augment the data. Thank you for watching the video.